Hi guys, good morning, good afternoon, good evening for the folks across the globe. So basically today we're going to discuss about what is Kubernetes is and why Kubernetes is used for and how Kubernetes works internally. To have a deep dive session, we need to understand or have a knowledge of what is containers at first. If not a problem. There is a link provided in this video to understand what is Kubernetes is. That is my video. You can go have a look on that and then you can come back for this Kubernetes session to understand what is Kubernetes and why it is used for and how it works internally. Okay. So before getting into Kubernetes, let me tell you what is monolithic architecture, what is microservices architecture, and what is the reason behind I'm explaining this in Kubernetes session. Okay, let's discuss monolithic architecture. For example, it is a traditional monolithic architecture is a traditional way of building application in which all the business functionalities and the modules for each application would be built by a single team and it would be built as a single deployment and it will be deployed into the application into the server and it can be accessed from there. Okay, what are the disadvantages of monolithic architecture? Okay, is what we're going to discuss now. Let me take an example. We have an application in ABC in which it has five different modules or functionality. Let me tell, each functionality need to be written on the same programming language. Assume my application is in a Java application, each business logic or each functionality, each module to be written in the same programming language across all the five modules, and uh, it has an difficulty in it doesn't have a better CI/CD deployment model if it is going to be monolithic architecture. And out of these five modules, one module or one functionality is going to have a higher usage. It is not possible to scale that particular module or functionality alone among these five modules as an application. And the final drawback is if any one of these five module functionality is going to go on, my entire application is going to go on. So because of this, there will be an application downtime. So these are the hard points in monolithic architecture that has been addressed in the microservices architecture. Assume I'm going to develop the same kind of application in the microservices architecture, out of which an application is going to have five different functionalities or modules. Each functionality will be developed in each functionality will be developed as a microservices, and each microservices can have its own programming language. Assume there are five microservices which is going to represent its own functionalities. Each microservice can have its own programming, as I said. One, the first microservices can be of Golang, the second microservices can be of Python, the third microservices can be of Java, the fourth microservices to Node.js, and the fifth as any other programming languages. Okay, and each microservices communicates through each other through an API calls. And each microservices can have its own database or it can have its common database to write its data. And it has a better CI/CD model deployment in a microservice architecture. And if any one of these five microservices which relates to the business functionality needs has high demand and needs to scale independently, they can scale independently without affecting or having dependency on other microservices. The last point is uh, if any one of these five microservices going to go down, the other four microservices is not going to get affected. The application would still be up and running. So these are the scoring points of microservices architecture compared to monolithic architecture. But at the same time, microservice architecture also has its own disadvantages. I would say, from my point of view, it has an complex networking when the communication is going to happen across microservices in the microservices architecture. Now, coming back to our old point, why this topic in between Kubernetes discussion. Microservices architecture told it has many microservices where we can deploy each microservices into separate pods and it can be scaled up or down based upon their requirement. Okay, so and these containers, okay, that is going to run inside my pods, okay, and these pods can be scaled up and scaled down, and all this orchestration need to be done by Kubernetes. So Kubernetes is what used for orchestrating the containers, managing the containers, and scheduling the containers. So now I think there is an connectivity which you guys able to understand the connectivity between the microservice architecture and the Kubernetes, and why not the monolithic architecture nowadays, and why microservice architecture nowadays. Now let's get into exact Kubernetes architecture. So basically, this is the difference of differentiation between microservices and monolithic architecture. In monolithic, everything's tightly coupled. In microservice, everything's loosely coupled, and scaling granular is not possible, which means each module or functionality cannot scale independently, whereas microservices, each module or functionality can scale independently as a microservices. And deployment dependency, if I'm going to do any deployment for a particular functionality, I need to bring down the whole application and you deploy it as a whole new application, where that is going to have a downtime of entire application. Whereas in microservices architecture, if any particular microservices need to be deployed, I no need to bring the whole application down. The particular microservices need to be deployed. That also can be done without a downtime. The entire application is not going to have a downtime, and if particular microservice is going to go for a deployment, it also wouldn't have a downtime. We have many CI/CD deployment model available, like blue green sorry canary deployments, or blue green deployment, like many deployment models available, which makes high availability of the microservices. That is separate topic which I can discuss in my future videos. And the next point is fault tolerance. If any of the functionality or something has an issue, the whole application will be down. Whereas the microservice architecture, if any of one microservices out of 5 microservices, as I told before, is going to have a problem, the entire application is not going to go down. Only particular microservices need to be addressed, or it's going to have a downtime. And no hybrid technology. For example, I can use only one programming language across this entire application stack, but whereas the microservice architecture, each microservice can have its own programming language, and it can communicate to each other through an API calls. By this, I would summarize what is monolithic and microservice architecture. Now let's get into exact what is Kubernetes and what is Kubernetes made of. So before getting into the Kubernetes architecture, I would like you guys, I would need you guys to understand some basic fundamental elements what we keep hearing here and there when Kubernetes topics is discussed. That are what is pods, what is containers, what is replica sets, what is deployment, and what are services. Okay. So assume here the outer box, the thin box, as one node. One node means one virtual machine. Inside that virtual machine, I can have multiple pods. Okay. A pod is nothing but a logical entity where it has logically partitioned. Assume my node, that is my virtual machine, has 90 GB RAM and 90 GB storage. I can build each pod of 30 GB RAM and 30 GB storage, like pod 1, pod 2, pod 3. And each pod will have a containers within it. The containers can be one to many. But in enterprise level, we have a best standard practice of having one-to-one pod to container, which means one pod will have only one container within it. Okay. And container is the place exactly where your application will be running. As you see here, the relation goes something like this. There is a virtual machine, and there is a pod inside that virtual machine, and inside the pod there is a container, and the application will be running inside your container. So this is the hierarchy from top to bottom. Now comes what is replica set. During writing my application, there is a manifest file we used to use as an YAML file. In that, I can say a statement referring to replicas as 3, which means the same copy of your application would be replicated in 3 different pods, and these 3 different pods can be on different nodes as well. Nodes means my different virtual machines. For example, I'm going to say that I have an Kubernetes machine with three nodes, which means three worker nodes, which in turn means three different virtual machines. Okay, so these three different virtual machines, inside that we'll have a pods. Okay, if I'm going to make replicas as three, pod one would be running on VM1, pod 2 would be running on VM2, and pod 3 would be running on VM3. So by this, I have high availability of pods. So any of this pod goes also, the other two pods will be able to serve the application as an high availability. That is defined through replicas in a YAML file. That is the concept which is defined here as a replica set in the diagram. And then coming back to what is deployment. Okay, so deployment is nothing but, okay, an application is going to, I have an application that I'm going to deploy. It is set as deployment. Very simple. Okay, and there is a final topic what I need to explain here is service discovery. Okay, basically a single pod or replica set can be exposed to the internal or external consumers via services. Services enable the discovery of pods by associating a set of pods to a specific criteria. Pods are associated to services through key value pairs called labels and selectors. A new pod with labels that match the selectors will automatically be discovered by the services. So let me explain this in detail. What is it? Assume I have a application ABC which is running in different pods, as you see here, pod 1, pod 2, pod, there are three pods. The three pods are running the application ABC, for example, the same application with a high availability of pod A, pod B, pod C. For example, I'm going to create a new pod, okay, named pod 4 with the same label and same selectors as pod 1, pod 2 and pod 3. Okay, the services that can be a type load balancer, which will be the application exposed point, and this fourth pod what I'm going to bring up with the same labels and selectors would be automatically discovered by the services, and these services discover the pod automatically, and this process is what as known as service discovery. Okay, so this is the fundamental blocks and elements of Kubernetes in the worker nodes and some master node pieces. Now let me come to high level Kubernetes architecture. So basically Kubernetes architecture means there are two pieces. There is a master node and there is a worker node. Okay, so the master node is the control plane which controls the entire Kubernetes cluster of which node to run which pod and the high availability of pods as well. And in worker nodes, that is node 1 to node n, as you can see, there would be a process named kubelet that would be running on top of each and every node. Now let me come to the components in master. There are there are four components in masters. One is API server, second is controller manager, third is scheduler, and fourth is etcd. Okay, what is API server? Whenever I'm going to make any communication to my Kubernetes cluster, the first communication goes to my API server, and the API server listens to what is the command, and then it communicates all the way down accordingly. So to make it simple, it processes the REST operation, validates all the incoming requests, and updates the corresponding objects in the etcd. Now let's see what is etcd. So etcd is a distributed consistent key value pair store used for config management services. And this is the metadata of this etcd holds a metadata of the entire Kubernetes cluster. So it is good practice to keep frequent backups of this etcd. In case of any failure of any Kubernetes cluster crashes, this etcd would be a core important backup to restore or recover this Kubernetes cluster. And this etcd is where it has information metadata such as like what node exists in cluster and what machine type of what type of nodes, that is for example it is having machine type 1 or machine type n1 or machine type n2 or any gpu that is running as a part of kubernetes cluster. All these nodes information is being captured in this etcd as a metadata, and which application is running on which containers and which containers is running on which pods, all these information are as well in etcd. Now comes scheduler. So whenever there is an communication happening from outside world to this API server, the API server internally invoke the scheduler. Okay, and this scheduler will decide where to run the pod and return that information back to my API server. And this API server persists is to an etcd, since because etcd, as I told before, it holds the metadata of the entire cluster. And this etcd notifies this information back to my API server. Okay, so with this information, API server invokes the kubelet in the corresponding node. As I told before in my previous slide, each and every worker node will have a kubelet process running on top of it. And this kubelet services on each node talks to the docker daemon using the API over the docker socket to create a container. And in turn, this kubelet updates a pod status to the API server, and this API server will push the information back to my etcd server. So by this, the entire process of invoking creating a container and running an application in container, all this metadata is captured in etcd. Now coming back to controller manager. So controller manager is, it watches etcd for changes to replication controller objects, and then enforces API to the desired state. Enforces the API to use the API to enforce the desired state. Which means, for example, if in my YAML file I'm going to make a statement saying that my replicas is 3. So these 3 copies of replica across my Kubernetes cluster has been controlled and managed with this component in my Kubernetes cluster. Okay, so let's wrap up at the last theoretical concept of what is Kubernetes is. So Kubernetes objects is pods, replica sets, and services submitted to the master. So based on the application availability of resources, master schedules the pods on specific node. Node refers to the worker nodes, that is eventually a virtual machine at the backend. The node pulls the image from the container image registry. So what is container image registry? So container image registry is the repository where we'll have our application images stored in it. Docker has its own container registry, and as well, for example, if you're going to talk with respect to AKS, we have ACR, that is Azure Container Registry, and in GKE Google Google Cloud, we have an its own container registry, which is known as GCR, Google Container Registry, where you can have its application images stored there. So as I told, ETC is an open source distributed key value database from CoreOS, which acts as a single source of truth for all commands Kubernetes. The master queries ETC to retrieve various parameters of the nodes, pods, and containers. So this gives an explanation of what Kubernetes is, as I explained before. So you see here, first a user comes in and he uses a kubectl create-manifest.yaml file, which will define what application I'm going to deploy. Is it going to be in Python or Node.js, blah blah blah. And I can tell replica copies all this information, and I'll communicate, write this manifest file, and I will submit this manifest file using kubectl create-f manifest.yaml file. This will go to my master, and all these process of as I told before, when the first I issue this command, it will communicate to my API server, and my API server will make a communication to my scheduler, and my scheduler will now create the pod, and then this information would be sent back to my etcd to persist, and based upon the replicas, my controller manager will spin the replicas in my Kubernetes cluster. So this is what happens at the high level. Now, let me give a very simple explanation or practical session of what and how this Kubernetes works. Okay. So this is my personal Google console. So let me create a new project. Let me tell Kubernetes demo 01. Let me create it. Okay, once that has been created, let me switch to that workspace. Let me just a minute. Okay, it's done. Let me get into it. Okay, so basically this is my Google Cloud Console. Now I've created a project. Okay, assume a project is a workspace where it is defined only for one particular project. Okay, Anna, you can see in the left there are many services here. You can you see it across. The list of services which is classified into particular groups: compute, storage, networking, stack drivers, tools, big data, artificial intelligence, blah blah blah, so on. Okay. So interestingly here, let me give a couple of information about Google Cloud Platform. So all the communication that is happening in the Google Cloud Platform is through Google's private backbone network. It doesn't hit into the public internet. So by the way, it is more secure and fast as well. Okay. And if I'm going to use the compute engine, so that will be through an API calls here. So that's the reason whenever we're going to use any compute engine or Kubernetes engine, we need to first invoke its APIs. So if, for example, if you're going to use compute engine, I cannot go directly use it. If you click on compute instance engine, my Google Cloud Platform will automatically invoke its API at the backend. So that is what you see it here. Compute engine is getting ready. So similarly, if I want to use my Kubernetes cluster, okay, you see here, if you go to clusters, you'll get a very interesting message here saying that Kubernetes engine API is being enabled. So finally, if let's take one more example. Mm, okay, container registry, because this is the component what we'll be using in our application now. So if I go to this images, okay, so this will also enable my API at the backend. So now we have enabled the APIs. Now let's start working on this project. So this is the activation of Cloud Shell. I have activated the Cloud Shell, and let me maximize this to a new window. Okay, so I need to set this to my particular project, gcloud set project, and I need to get my project ID. So I need to go to this Google console and I need to copy this project ID. So project ID is different from project name is different from project ID in Google. Okay. So project name is what you give a project name, and a project ID is what Google assigns by itself, and it is a unique value. Sorry, I missed the keyword. So once you have set, you can see that I am now into particular project. Okay. I okay. So let me clean up my old stuff to to make it very easy for you guys. Okay. So let's get back to our old presentation. Okay. So I have my sample code in my I have my sample code in my git clone in my GitHub. So let me do a git clone. So it has cloned it to my local directory. Let's see it. Okay, let's go to my sample Kubernetes GKE. Okay, profile. Okay, so basically the application what I am using here is an it's a Python application. Now what I do is I will package all my code into an Docker image. Okay, so I'm going to use this command docker build -t. Okay, so what this command does? Okay, so GCR is an Google Container Registry.io. Okay, so dev shell underscore project underscore id. So what does this dev shell project underscore id is an variable what I'm going to use it here, which refers to which refers to my project id. So the image what I'm going to build out of this, the output would be gcr.io slash this project id slash hello world hyphen a slash v1. So this is what this command. Okay, so so what does this command does did for me? Okay, if you see here, okay, it has pulled, it has installed. Basically, I told it's a Python file. Okay, in my Docker file, I would have specified the command to. I would have specified that I'm going to use Python library, so it will automatically download all my Python related libraries, and it would have installed all my Python libraries. Okay, and its dependencies as well, and my simple code as well. So by this, all the dependencies has been downloaded, all the Python libraries has been downloaded, and the Python dependencies has been downloaded and installed, and my application code, what I have in my local machine, also has been built into an Docker, also been used to build it as a single Docker image, and the Docker image would be of name gcr.io. The dev shell project ID, as I mentioned before, is a variable which denotes this Kubernetes demo 01253914, my project ID. Hello-la would be my project, would be my application name, and v1 would be a version 1. That's it. So to confirm this, okay, I'm going to just run issue the command docker images. So you can see it has built a Docker image, okay, which has encapsulated my Python libraries and the dependencies and my application code into a single image, and the file size is of 188 MB. So this image I can now run it as in containers. So as I told in my previous video on containers, this will be of a lightweight format, which means that the whole application is of 188 MB now as an image. Now the image is ready. Okay, now I need this image to be pushed into a repository, centralized repository, where I can push and pull across my environments to deploy the application. So let's see how to do that. Okay, first I need to authenticate gcloud as an docker credential helper. So for this I need to use this command. Done it. Okay, it's registered correctly. Now I need to push docker container into my container registry. Okay, so what is the command I'm going to use here is docker push, and then this command. This command is, sorry, this is not a command, it's an image. Okay, so now it is preparing to get pushed to my container registry. In the meanwhile, okay, if you saw earlier, okay, there was nothing in my container registry. Okay, still it is not nothing. So once this command completes, you can see the Docker image what we built earlier will be pushed to this Google Container Registry. Okay, so now it is done. So let's see. Let's refresh the container registry of the project. Here you go. Now you can see the application named hello-la image has been moved to my Google Container Registry, and this is private. Okay. Now my image has been pulled. So the next point is I need to create my Kubernetes cluster. So let's create a Kubernetes cluster. Gcloud containers cluster create a demo cluster. Mission type. Let me put as um, standard N1, and then let me specify the zone as US Central one hyphen C. Sorry, that's typo. Hmm. Machine type unrecognized. So give me a second, guys. So let me find where the issue is. Okay, got it. So that's a flag being missed. Here you go. So now the cluster is getting being created. Sorry for that. It's my bad. I missed the flag. So this cluster creation might take between 2 to 5 minutes. So let me pause the video and get back to you once it is done. Thanks guys for waiting. Now my Kubernetes cluster is ready. So you can see My Kubernetes cluster name is GK demo cluster and location is US Enron FNC, and my version of cluster and my master IP and my machine type and my node versions and my number of nodes and the status of Kubernetes clusters running. So basically, which means it's a three node cluster of version 1.13.7 GKE.8, and it's been hosted on in a US Central 1 seed zone, and the type and the name of the cluster is GKE demo cluster. Now let me authenticate to this cluster. Cloud clusters get credentials GKE demo cluster. GKE container clusters get credentials. Okay, I need to use the flag zone. Central one I can see. Okay, now authenticated to my Kubernetes cluster. Now internally what has happened is, so this is my authentication, which is I'm authenticating to my Kubernetes cluster named GKE demo cluster. So I'm first hitting my API server in my master node, and this API server, the master node, is going to my ETC, which is having the metadata to get authenticated and get back to the API server and get back this message that it is entry generated for GKE demo cluster. Okay. Now I am going to deploy the GCR image what I have in my Google container registry. So very simple it is. So its command is kubectl run hello-la is my application name, which is in this repository, and I'm exposing this to port 80. Okay. So now let's see kubectl get pods. So now you can see there is an application named hello-la. Okay, and this is the container ID followed by, okay, and the status is running, and it is running for last 10 seconds. Okay, so let me go and see the deployments. Kubectl get deployments. Okay, this is my deployment name hello-la, and it is running for last 32 seconds, and it is there is only one deployment available as of now. Okay, and now the application has been deployed, but it is not exposed to outside world. So if you want to see kubectl get services, you will be seeing only one, that is my Kubernetes cluster. So basically, let me tell what is your type. Cluster IP means, the cluster IP means it is the type of service that has been built, that has been listed here, which means this cluster IP is the IP that has been that would be used internally for communication across my that would be used for communication within my Kubernetes cluster itself, and it is not exposed to the outside world. That's the reason you can see the external IP here as none. Okay, and it is through the secured communication through port 443, and this configuration information, this services would be exposed by the time that during the time when my Kubernetes cluster has been created. Now I need this application to be exposed to my internet is what, then only the application end users can access it. So now we're going to see how I'm going to expose that to my outside world. Okay, so sorry, I couldn't recollect the syntax. So let's create a load balancer type. Okay, so basically, what I'm going to do is I'm telling my Kubernetes. Okay, I'm telling my Kubernetes master that kubectl expose deployment. Okay, and my deployment name is you can see from here it is hello-la. You can see it here. It's hello-la. So I will copy the name hello-la. Okay, and then I will tell my type as load balancer. And I will tell the type as load balancer. Okay, and then my port as 80. Okay, so it should be of unit caps. Okay, now I have deployed I have used this deployment hello-la and exposed it as an services using the load balancer type and to a port number 80. So basically I've created a load balancer and exposed this as a service to my internet. Now let's go to this command kubectl get services. Now you can see there is an application named deployment named hello-la of type load balancer, and this is my cluster IP, which is for internal communication. External IP is pending still to be provisioned yet, and it is exposed to port number 80 and it has been provisioned last 23 seconds before. So let's see now the services, and still it is in pending state. Let's see after a minute. Still not yet. Yes, here you go. So let me copy this IP and let me give an port number 80. Still loading. Come on. Here you go. So you can see my application, the message getting from Rajesh Kubernetes Academy in GKE. So to wrap up this, I've told what is Kubernetes and I have told what is containers in a previous session and went in depth of in Kubernetes, what is master node and what is worker node, what is an architecture inside my master node and what is the architecture inside my worker node. And I have created a sample image in my Kubernetes. I deployed my sample in application in my Kubernetes cluster as a deployment and exposed it as a service. Okay, so finally now we see how to scale this get pods. As of now I can see only one pod. Okay, now I need to scale this. Scale deployments. Hello, I replicas equal to 3. Sorry. give command hyphen replicas equal to 3. So I have for that. Let me just think for a minute. So we can do this. Okay. Give me a minute, please. So here, so I've given scale deployment. Oh, again the same mistake what I done earlier. So it should be my, since the flag I need to give an hyphen hyphen. Okay, and that should be word as deployment, rather deployments. So let's see. Yeah, perfect. So you get pods. So now you can see the container is getting created. These are my containers, which is already scaled. Cool. Now it's running. Okay. Now I can again scale down to 1. You can see the other containers will be terminating by this command kubectl get pods. Yes, the other two are terminating. So by this you can scale up and scale down your deployments in particular nodes. Still it is terminating. Okay, so it will be terminated. So here we can even kubectl get pods. Okay. That's very beautiful command. Hyphen hyphen o. Sorry. Get pods hyphen o wide. Okay. So you can see the other two pods is already terminated. So I would like to go to this. This is my pod ID. So it gives a detailed information of the pod. So I can investigate the log of this particular pod by using this command kubectl logs and then followed by pod ID. If you're going to hit this, you'll get my log for this particular pod where you can see all this informations. So here you go, and as well you can do an vertical scaling of this pods. Okay, So how this is possible is there are commands where we can use to do an horizontal pod autoscaler, and the command here it goes kubectl autoscale deployment hello hyphen la, okay, and then followed by hyphen enable auto scaling minimum nodes. I can tell the minimum nodes as 2, and then I can tell my maximum nodes as 3, or so on. How many number of nodes you have, that doesn't matter. That matters. Sorry. Sorry. This is for this is not the command it is. So we need to enable the auto scale. Okay, deployment name, and then maximum. I can tell that you can go to 6, and then I can tell minimum as 3. So the scaling criteria should be my CPU, that I can tell my CPU 50 percentage, for instance. So auto scale, all it should be non deployment. Okay. So I have enabled my auto scaling. So whenever my CPU goes beyond 50%, it might scale up to 6, and if my CPU is below 50, and it might scale down to 3. So by this you can do an auto scaling, enable auto scaling as well. So by this I would like to conclude the session on Kubernetes today. Hope you guys enjoyed. Sorry for at the last I was having some issue and typing some commands because there are too much commands. There was some typo errors. I'll try to improve that as well. Thanks a lot. Thanks a lot for watching. Thanks. Bye bye. Have a nice day.